3. This lesson is covering 5C.5. The topic is law of cosines. After the warm-up, you ran into some triangles that you couldn't solve with law of sines. Yet side, 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 side angle, side can be solved. They can show congruency using law of cosines. So here we go. We use the law of cosines to solve oblique triangles when we are given side, 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 or side angle, side. Notice we say oblique because if I have a right triangle, I wouldn't have to use law of cosines. All right, so here's where law of cosines comes from. Let's say I have a triangle. And this is angle A, side A, angle B, side B, angle C, side C. All right, now let's break it apart. We're going to drop a height here, an altitude. And we're going to call that H for height. Now, that breaks up my base into two pieces. I'll call this piece over here an unknown x, and then this piece over here would have to be the total distance, c minus x. Okay. Now, I can use right triangle trig on either of these two right triangles that I've created. And I can also use Pythagorean Theorem, right? All that fun, good stuff, because I've created some right triangles here. So step one, let's say I'm interested in angle A here. So looking at just this triangle on the left, I could say that cosine of angle A will equal the adjacent over the hypotenuse. Solve that for x, and I could say that x is equal to b times cosine of A. Okay? I'm going to just leave that there for now, and we're going to come back and grab it again later when we need it. Okay, next off, we can use some Pythagorean Theorem, and we could say that x squared plus h squared has to equal b squared. Okay. Now I'm going to go ahead and do a little bit of work on that. X, I could say, well, before I do that, let's go ahead and do the same Pythagorean theorem on the other triangle over here. So let's go with c minus x squared plus h squared equals a squared. Okay, so we can all agree that these are correct statements since I have right triangles. All right, so let's FOIL this out, right? C minus x squared, that's going to give me c squared minus 2cx plus x squared. All right, that's just multiplying out that binomial, squaring a binomial. Now it's time to start taking this information over here and substituting it into this equation. So I can replace x with the statement of b cosine A. So this x right here, I'm going to replace it with this statement right here. Okay. And then I can replace x squared plus h squared with b squared. Okay. So you notice the goal here is I'm trying to get rid of the x's and h's because the x's and h's weren't in the original triangle, right? The original triangles had a's, b's, and c's. So I'm going to be replacing all the x's and h's with a's, b's, and c's. So writing my new equation, I will have c squared minus 2c, and again, I'm going to replace this x with an equivalent value of b cosine A. Okay. So I take them over there. Now I'm going to replace my x squared plus h squared with that b squared, because they're equivalent. Okay. I now have a statement that is only using a's, b's, and c's. And so I use some right triangle trig to kind of create this new setup. So I'm just going to rewrite this new setup in a more clean manner. So let's write it as a squared equals b squared plus c squared minus 2. I'm going to make that a bc, alphabetical, just because I can, times cosine a. And ladies and gentlemen, there is the law of cosines. We can rewrite it in terms of any of the other sides, right? This is written in terms of side A. We could also rewrite it in terms of side B and in terms of side C. So rewriting it in terms of side B, we would have b squared equals a squared plus c squared minus, and now it's going to be 2ac, and it's going to be cosine of angle B, right? So it's always the side that we're interested in and the angle opposite. And then rewriting for side C, it'll be c squared equals a squared plus b squared minus 2ab cosine angle C. Okay. So there we go, law of cosines. Now, sometimes based on the triangle, we're interested in solving for the angle, not the missing side. So that's the next question on our handout. Another useful form of our law of cosines equation is to solve it for the angle. So if I take this equation right here and let's solve it for the angle. Okay. So we want to subtract b squared, subtract c squared. Now we're going to want to divide by negative 2bc. Okay, and the last step to solve for angle A, I got to do the inverse cosine. So angle A will be equal to the inverse cosine of that quantity. So notice it's the same formula. There's really no need to memorize it unless you want to. It can save you a bit of time. You can always just start with whichever one of these you have the information for. Plug in the information you have. And again, you must have all the information except one of the unknowns. And then you just solve for that one unknown. You could continue if you want and solve the middle formula for angle B, solve the bottom formula for angle C if you wish, or you can just use, change things around on that guy. Okay, so there you go, law of cosines. Let's use it now. So on the bottom of the page, we've got two examples. Here's example A. Notice what I've been given, side, side, side. We can't use the law of sines because the law of sines requires an angle with the opposite side. We don't have that. But with law of cosines, we can solve this triangle. So we're going to go ahead and use law of cosines here. We have all three sides, so we can start in any place we want. Let's go ahead and find, how about angle C? So if I want to find angle C, I would start with side C squared. And then that's going to equal the sum of the squares of the other two sides minus 2 times the product of those two sides multiplied by cosine of that angle opposite C, or opposite side C, so that's angle C. Okay. So here's the instance where you might have saved a little bit of time if you use this alternate formula. But it's okay. If you don't want to use the alternate formula, if you just want to memorize the one formula, this will work. So solving, I'm going to have 15 squared minus 7 squared plus 9 squared divided by negative 2 times 7 times 9. That's going to give me cosine of my angle. Take the inverse cosine. Oops, that's a minus 9. Sorry about that. Okay, and calculator time. I highly recommend do it in pieces. Don't try to jam the whole thing in your calculator at once. A lot of mistakes happen that way. So I would do 15 squared, get an answer. Minus 49, minus 81, get that answer, and then divide it by that, get an answer, then do the inverse cosine of it. So do all that in the calculator, make sure you're in degrees. We should find, where do I have it written down? We'll see is 138.94, I believe. Yep, 138.94. Degrees. Now, the reason I solved for that angle first, I could have solved for any of the angles first. I solved for that one first because side C is the longest side. And if I find the greatest angle, I can now jump safely to law of sines without having to worry about any ambiguous case, because I now have an obtuse angle. So if you want to continue using law of cosines, you can use law of cosines twice more to find angle A and angle B. You could use it once more to find A or B and then subtract from 180. Or you can jump over to law of sines at this point and use your obtuse angle to find, again, one of the two missing angles. So you can go either route. I'm going to go ahead and I guess we'll do law of cosines once more. That's today's topic, but you can see that this is a little more work than law of sines. So typically, if I didn't have to use law of cosines, I would at this point jump over to law of sines, save myself a little bit of work. But let's practice some more law of cosines. So let's say we want to find angle A. So to find angle A, we start with side A squared equals the sum of the square of the other two sides minus 2 multiplied by the product of those two sides, and then cosine of that angle opposite that side. Okay, solve it. So let's see, A inverse cosine of and again, don't overload your calculator. We should find angle A is approximately 17.85 degrees. And this should make sense as you're solving the problem. Shortest side, that's smallest angle. Longest side, greatest angle. And at this point, we could use law of cosines one more time if we really love law of cosines, but I'm just going to subtract from 180. So my remaining angle is B. It's going to be 180 minus these two angles that we found. So angle B is going to be approximate 23.21 degrees. There you go. We've now solved the side-side-side triangle. Notice the instructions also say find the area. So that's a review. That's what we did last lesson with the law of sines, finding the area. Let's go ahead and find the area now. So remember what you want to do when you're finding the area. Make a right triangle here. This is our height, and use sine to find the height. So I know that sine of angle A will be the height divided by 9. And angle A I had over there. So my height is 9 times sine of 17.85 degrees. Multiply that by my base of 15. 1/2 base times height will give me my area. So my area will be 1/2 base 15. Height is 9 sine of 17.85 degrees. Working that out, it got cut off on my sheet here. Let's see, I wrote it down somewhere. Yeah. I get an area of roughly 20.69 square units. There you go, there's your first example. Go ahead and pause the video here. If you want to try the next one on your own, feel free. Okay, now I'll solve the next one. Notice the information given is different. The information given here is side, angle, side. So I can't use law of sines because I'm lacking the opposite side to the given angle, but I can use law of cosines. I must find this opposite side first. That's step 1. So I'm going to do the opposite side, that's c squared, equals the sum of the squares of the other two sides, minus 2 times their product, and then cosine of angle C, which I have. And there we go. Lots of calculator time. We'll find that c squared is approximately 229.214. Square rooting, we'll find that c is approximately 15.14. Okay. We now have all three sides. We got to go back and find an angle. We can use law of cosines to find that angle. We can use law of sines to find that angle. I'm going to go ahead and use law of sines at this point. It is faster and easier. So I can say sine of 28 degrees over 15.14 will equal. Now when I find that other angle, I'm going to go ahead and find angle B next. So sine of B over 14. Sine B is 14. 28 degrees. Inverse sine. Okay, and solving that should give me an angle of 25.73. And then subtracting from 180 will give me my angle A. Should find that to be 126.27 degrees. Now, sometimes, again, law of sines, we have some issues because sine, we've restricted it to quadrants 1 and 4, right? So whenever I'm doing inverse sine, it's never going to give me a value above 90 degrees. And that's why I purposefully went for angle B first, because I looked at my sides and I knew that side B was smaller than side A. So I knew I'm going to use law of sines to find that acute angle, because your calculator is always going to be giving you an acute angle when you use inverse sine. If I had tried to find angle A, the obtuse angle, using law of sines, I would not have gotten the 126.27. I would have gotten an acute angle. So that tends to mess students up. So anytime you're solving with law of sines and you have the option of which angle to find first, in this case, it's wise to find the acute angle first, and then we can subtract our two acute angles from 180 to get our obtuse angle. Okay, go ahead and stop. Oh, sorry, we have to find the area. Almost forgot. So area, again, drop down a height on our triangle, and I can say that sine 28 degrees will equal the height over 14. So I know the height is 14 sine of 28 degrees. Multiply that by a half and the base of 26, and we'll have our area. So our area should equal approximately 85.44 square units. Okay, so at this point, go ahead and pause the video, turn your worksheet over, and give the next problem a try. Problem C is a side, side, side. My cameraman wouldn't mind helping to. Yeah.
I can just edit it together.
Thank you. No. Okay. You still recording? All right. So, continuing on the back side, example C. If my camera person would mind picking up where she left off. All right. This one we are given side, side, side. So 14, 6, 9. B, this is C, this is A. Okay. So side, 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 we have to use law of cosines. Let's go ahead and do that. I would recommend, let's go after the largest angle first. Because if I have that largest angle first and then I want to jump over to law of sines, I'm safe. So I'm going to say that 14 squared equals the sum of the square of the other two sides minus 2 times the product times cosine of my angle, in this case angle C. Solving that. Calculator time, we should find angle C approximately 137.01 degrees. Okay, and I purposefully again chose to find that angle first because that's my obtuse angle. Now I'm going to jump over the law of sines to save a little bit of time. So sine of this angle divided by the opposite side equals sine of angle A divided by the side opposite A is 9. Solve it. And inverse sine. We should find angle A to be approximately 20, I can barely read Mr. P's writing. It's like 28 degrees. I hope that's what he wrote. If it doesn't work out, we can go back with the calculator and check that. Okay, now to find our last angle, angle B, subtract from 180. .99 degrees. Does that work out, or am I misreading that 28 degrees? I'm going to grab a calculator here real quick, guys. No, I'm misreading that 28 degrees. It must be a 26 degrees. I'm going to go ahead and enter this in my calculator just to confirm. Yeah, this should be 26 degrees. And that's the thing, as you're going along, you're going to potentially make a mistake if you're always watching out and making sure things add to 180, opposite sides are matching the right angle, not the right angle, the corresponding angle. You'll catch your mistakes and you'll be fine. Okay, so I now have all three sides, longest side, largest angle, smallest side, smallest angle. Let's go ahead and find our area. So I'll go ahead and drop a height. So let's see, we know that the height here, call that h. So sine of angle B equals my height over 14, my height equals 14 sine of angle B, and area is of course half base times height. Working that out, let's see. Oh, Mr. P didn't work the area out. Okay, let me put it in the calculator. I'm getting approximately 18.41 square units. Okay, so there we go, that's example C. Go ahead and pause the video now, try example D. Okay, so here's example D. We've been given side angle side, so this is a law of cosines problem. All right, so we have to start by finding this side over here. This is side B. So I know that B squared will equal the sum of the squares of the other sides minus 2 times their product multiplied by cosine of angle B. Okay. Calculator time. So we'll find that B squared is, Mr. P didn't actually work out the B squared, he just went straight for B. So B is approximately 21.21. And now that I have that info, I have to work on one of my missing angles. So down here is angle A, up here is angle C. So let's do law of sines. So sine of 97.5 degrees over 21.21 will equal sine of A over 14.5. So A is going to be the inverse sine of 14.5 sine 97.5 degrees over 21.21. So angle A will be approximately 42.67 degrees. And at this point, if you love law of sines and cosines, you can use it, but I am, of course, going to use an easier method to find angle B, subtract from 180. So angle B is going to have to be approximately, wait, why did I say B? Sorry, angle C. Angle C is going to have to be approximately 39.83 degrees. And now double checking everything, we find our longest side. It's across from our greatest angle. Our shortest side is opposite our smallest angle. And we find the sum of the smaller sides will exceed the length of the largest side. So it all works, it makes sense. Next, find the area. So we need to find a height. So we can go like this. There's my height. So I can say sine of, where's A? 42.67 will equal my height over 13.7. So my height is right there. My base would be 21.21. So my area, 1/2 base times height. And again, I think Mr. P forgot to do that, so we got the calculator. .47 approximately square units. And there you go. So go ahead, pause the video now, and try example E. Welcome back. Here's example E. I'll stop right here before I even get into trying to solve anything. Notice, The two shortest sides have a sum of 5. My longest side is 11. No triangle is possible. So, example E was a quick one. Move on, try example F. All right, welcome back. Here's example F. You'll see we have side angle side. So law of cosines problem. Always wisest to go after the largest angle first. So angle A would have to be a larger angle than angle B because side A is greater than side B. So I'm going to go after angle A first. So A squared. Oh, I'm sorry. I was solving it as if it was a side, side, side. Which is the beauty of this. You'll catch your mistake immediately when you don't have the information required. So I actually have to find side C first because I have angle C. So C squared equals sum of the square of the other sides minus 2 times the product. And the cosine of, in this case, 52 degrees. Solving. That should be much straight for C. You don't have C squared, so C equals, wow, 25. Now, I'm going to go after, if I'm using law of cosines, I would want to go after angle A first. But if I'm using law of sines, I would want to find angle B first because I know B must be an acute angle. So I'm going to go ahead and use law of sines and go after angle B first. So sine of 52 degrees over 25 equals sine of B over 28 and solve. And we find that angle B is approximately 61.92 degrees. So it was an acute angle, not an obtuse angle, which is good. That's what we want. We knew it had to be an acute angle because the side B was not the longest side. Now to find angle A, we can subtract from 180. And angle A, 66.08 degrees, which isn't surprising. Hopefully you realize since side A and side B were so similar, their angles can't be that far apart. So they're both acute angles. So I actually didn't have to worry about the ambiguous case on this particular triangle. Okay, and make sure some of our angles is 180. Yes, they are. Check that the shortest sides added together, 25 and 28, exceed the longest side, 29. They do. Make sure your largest angle, angle A, is across from your longest side. It is. Make sure your smallest angle, angle C, 52 degrees, is across from your shortest side, and it is. So this triangle makes sense. Lastly, find its area. So go ahead and drop height, and I can see that sine of 66.08 degrees will equal the height over 28. And area is a half base times height. Base is 5. And again, I don't see the area written, so let me pull up my calculator. I did approximately 319.94. Okay, and there you go. There's example F. So again, go ahead and pause the video here and see if you can put it all together at the bottom section. I didn't really want to erase this. I wanted to copy this down onto my salon. Okay, whatever, I'll erase it. Okay. The bottom section breaks things down into the various triangle types. First triangle type, if I have side, 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 whenever I have that, it's law of cosines. Okay. And it's wisest to find the largest angle first. Okay. Then I can use law of sines. Okay. Or you can simply use law of cosines twice and you're safe. Because remember, cosine will always give you values in quadrants 1 or 2. So values between 0 and 180, which are always correct. You're never going to have an issue. Its law of sines is going to give you issues because it will never give you an obtuse angle out of your calculator. So either use law of sines to find the largest angle first, then jump to use law of cosines to find the largest angle first, then jump over to law of sines, or you use law of cosines twice. Either way, that's a safe approach. You're going to get the right answers. All right, next triangle type. When I have side, angle, side, I have to use law of cosines. Okay, got to use that first. Once I do that, I'm going to have all three sides. I can then jump over to law of sines. And find the smallest remaining angle. Again, because your calculator will not give you an obtuse angle when you're doing the law of sines. So make sure you're finding the smaller of the remaining two angles. It'll be guaranteed to be acute. Then you can simply subtract from 180 to find that last angle. You'll be safe. I always get lots of students that don't follow that step, and then they find out, hey, I don't have the largest angle opposite the largest side. What went wrong? Well, what went wrong is your calculator's never going to give you an obtuse angle using inverse sine. That's what went wrong. So find the acute angles first whenever you're using law of sines. All right, next triangle type. We've got angle, side, angle. Okay. On this guy, step one is find that third angle, right? Subtract from 180 to find the third angle. Okay. At this point, jump over and use law of sines to find your missing sides. You could, of course, if you love law of cosines, use law of cosines. But typically law of sines, faster, easier for most students. All right, now we have an angle-side triangle. Again, anytime I have two of the three angles, my preferred first step, subtract from 180 to find the third angle. Okay, and then again, law of sines. Okay. Notice, by the way, I'm never saying Pythagorean theorem. There's always students that say, oh, we use Pythagorean theorem. No, you're not, because these are not right triangles. Remember that. You must have a right triangle to use Pythagorean theorem. Okay, we've got angle, angle, angle. And of course, this one we can't solve, because there's an infinite number of possible triangles that have the same three angles. And the last one, the hardest one, is the ambiguous case, side-side angle. Okay. This is what we went over last time, so I'm just going to stop right here. Go back, review how we handled this last time. Remember, you needed to figure out the height of the triangle. You compare that height to the side length, and then you decide, do I have 0, do I have exactly 1, or do I potentially have 2? Then you research the potential when you have 2 and solve. Okay? All right, that's it for this lesson.